Hi, do you want the remote control level crossing like this? Do it yourself. You will need this set of PCBs and electronic components. Let's start with crossing signals. First we need to fix the PCB somehow so it won't run away. Any tape is good. The best one is a paper masking tape. There are two PCBs. The first one has two LEDs. The microcontroller is in the middle. It is oriented with the LED plus signs on the top. The second one has one piezo buzzer in the middle. The microcontroller is on the left side. Let's preheat the soldering iron to 330 degrees Celsius. We are going to connect these two boards together with wires. I have this copper wire that is thin plated. It is very good. You can use any other copper wire. The reason why it is not one board is the multifunctionality. The bottom PCB can have either buzzer or one wide LED mounted on it. In some countries like in Czechia or Slovakia, there are crossing signals with white light, which signal safe crossing, and you can drive faster through it. Look at this small integrated circuit. It's a microcontroller. The small dot in the corner indicates the first pin. On the PCB there is also a small dot that indicates the first pin. So don't mess up with the pins. There are many ways how to solder SMD components. If you don't have special tools and materials, follow this. First, put a small amount of solder on the pad. Then use tweezers to put the component on the place and solder that one pin. Continue with other pads. Use only a really small amount of solder. It is very good to use flux. If you put too much solder on it and it connects two pads together, use flux and some wires to remove exceeding solder. The microcontroller is pre-programmed. There are like 45 lines of C code that does all the things like flashing the lights and making the sound. You can download this code from GitHub. And now I will run it a bit faster. These two small things are capacitors. They go on a place labeled C1. Put solder on one pad, then use the tweezers to hold the capacitor on the place and solder it. By the way, these capacitors are there to protect the microcontroller from voltage spikes. It is more comfortable to turn the PCB and then solder the other side of capacitors. And now the diodes. They are labeled D1. There is a white stripe on one side of the diode. It is a cathode. Well, you don't need to know the name now. What is important is the white stripe of the PCB. They have to match. Solder it the same way as capacitors. The diode conducts the current only one way, so it protects the microcontroller from reverse polarity. This one is SS14 Schottky diode. The main advantage of this diode is that the forward voltage is very low. It means that it does not lose too much power. You can see that the package is quite huge compared to common SMD components. It is because I choose this size for easier soldering. Now turn the PCB to the other side. Here we have the piezo buzzer. It goes to the other side of PCB. The problem is that the leads do not fit on the PCB. We must adjust the distance between them a bit. You know, sometimes they deliver a different component even though the other dimensions are the same. Be aware of orientation. There is a plus sign on the top of the PCB and also the buzzer from both sides. After soldering, cut off the excess leads just 1 millimeter above the board. Now the LEDs. In the package you can find 4 diodes. They look the same, so I marked white diodes with black dot on the bottom. On the PCB there is a plus sign on the bottom side of the board. On LED the longer lead is a plus, the shorter lead is minus, of course. Spread the leads apart a bit so it won't fall off the board. It's always good to fix the PCB and components so it does not move. Use this third hand tool. Usually I solder one lead of each diode first, then I can adjust the position and only then solder the other lead. Cut the excess leads. Now we will connect the power leads. It goes to the board with buzzer. Definitely some helper hands are needed. The color does not matter much. Later we test the right polarity. And by the way, this is not the right way how to solder wires. You can't bring solder on the iron to the connection. There is a flux inside the solder and it will evaporate this way and it won't work well. So it is done and we can test it. I will just connect the wires from the control panel. It's basically a 3 volts power supply with changing polarity. Let's start with the second part, and the first component is the motor. This is an N20 motor with gear ratio 1 to 30 or 1 to 60. We must find the correct polarity. Even though there is some marking on the box like this red dot, it is not very reliable. Put the motor on the bench top with leads facing to you. When you connect 3 volt plus on the right lead and the minus on the left, the motor should start turning to the left. I mean counterclockwise, viewing from the backside. Now fix the motor in some clip and we will use leads from diodes to connect the motor. Solder the ends of diodes to the motor. Then cut the leads in half. Well, maybe I will need new pliers. This is the PCB and we are going to solder the micro switches to the PCB. The best way is to use some tool like a third hand to hold it together. I will show you one trick how to do it by hands. First place the solder at a suitable height, hold the switch and PCB in one hand and the solder iron in the other. Then try to hit connection and add solder to it. Oh, sorry for bad focus. You need to solder just one lead this way, then put the PCB on the benchtop and continue. The diodes are connected in parallel to the microswitches. You can see the white stripe on the diode itself and also on the PCB. Bend the leads and push them through the holes. On the other side, spread the leads apart so it does not fall off the board. And now solder the leads. Oh, now you can see how useful it is to fix the PCB somehow so it does not run away. And now cut the excess wires. The last part is the motor. Form the shape of the leads and connect it to the board. Solder the leads and cut the excess wires. Now we add some power wires to the board. Again, color does not matter at this stage. Now it's time to test the board. Connect the wires to the power source and the motor will start rotating toward the right limit switch. When you press it, the motor stops. When you press the other switch instead, the motor keeps running but at lower speed. This slower speed is caused by the diode connected in parallel with the microswitch. The last module is the connector board. There are 2 terminal blocks and 3 pairs of holes for wires. One terminal block is for power source, connects to the control panel. The other terminal is for the connection to the opposite barrier on crossings. Here you can see that the soldering with PCB fixed by third hand is more convenient. We can solder the wires of signal board right away. For the motor board we need to do some testing first. Connect the source of the terminal block with the polarity that activates the signals. Now take the motor. Imagine this screwdriver is a barrier. It should rotate counterclockwise when signals are on. Take the wires from the motor board and connect them to the board. No solder yet. If the motor is rotating in the right direction, remember the position of the wires. Here it is blue on blue, but it's just coincidence. Now we can solder the wires. Cut the excess leads of terminals. So we are done with all the electronic soldering work. Let's take all the 3D printed parts and assemble them. First, put a terminal block and put it into the back of half of the box. Then put a signal pole on the place, but push it only the halfway. Place the wires of the signals into the pole and cover them with this small part. Well, I don't know how to name it. Then push the pole connector all the way down. Put the motor board on the place and organize the wires into this cavity. Cover the signals with black cover. Later you can super glue it to fix it. There is a thin channel around the box for the glue. Well, it's not easy to close the cover. We need to pull the motor out a bit and then tilt the front cover so it pushes the switches down. When everything is in place, fasten the parts with the screw. For mounting the barrier, we need to rotate the shaft to the right position. The flat side must be parallel to the side of the box. To complete the level crossing, put a pair of wires between the parts. It looks more difficult than it is. Fasten all 4 screws, connect the wires, and it's done.